So my name is Craig Everett. I'm the Chief Product Officer at QPQ AG, and our basic proposition is that we have solved blockchain. That's a big, bold statement, and it's been said before, but we actually have. What needed to be solved in blockchain? Well, the long story crunched down to a single slide is that Bitcoin and Ethereum were good proofs of concept, but they are not production ready. Somebody sold the demo to the world, and it's just a demo. It doesn't work. It falls apart when you put any pressure on it. 3 transactions per second is not enough to run a global economy by any means. Everyone knows that, and so we've had a buzzword of the month competition cycle in the crypto world, and everyone focuses on problem X, and a whole new blockchain shows up to solve X or whatever, and it's all fueled by number go up. It's purely speculative. Nobody's looking for utility. They're all looking for speculation value, and we view that as poisonous. Um, so just examples of what's not lining up good. The EVM, the Ethereum Virtual Machine, it's a broken and dangerous system, which that doesn't mean it's bad. It's a very good proof of concept. They proved the point. You can make an evolving state machine that has a language that you can write. We call them contracts, but they're little programs that evolve that state in a set way. It's laid out in program code. Um, the problem being that any proof of concept virtual machine is going to have gaps in it, and you have to go back after you've proven that a certain virtual machine concept works. You have to go back and properly design a virtual machine. Fate is such a machine. The same goes for language design. Solidity is a dangerous, bad language. Sophia is good. Language design is a tricky, fraught subject, and Solidity is an informally specified, let's just try this and see if it works, attempt at it. Anybody who knows how hard language design is knows that you would do that kind of as an internal project, see if it works, and then go back and go, okay, that was a great proof. We've proved that this is a good idea. It's productive. Now let's go back and fix the VM and write a language that's worthy of it, and so on. That never happened with EVM. That just went out. It got big. It blew up, and now we're stuck with it forever. Kind of like JavaScript, sadly. Sophia, on the other hand, is a fantastic language. I hate every language at least a little bit. Sophia is one of the genuinely like good ones, and I can count them on one hand. There's not very many good languages out there. Bitcoin and Ethereum are too long latency. So if I try to buy a cheeseburger with either one, I'm done eating it before a transaction for it would have gone through. That's not a thing you could build an economy on. And layer twos, I don't have it listed in here, but layer twos that try to solve that problem. The parent chain is not aware of the child chain, which is effectively what a layer two is. And because of that lack of awareness, you don't know what trade-offs you're making when you get into a layer two. And it's all ad hoc, slapped together with huge security gaps that pop up over and over and over. Everything from wallet weaknesses to just the basic protocol between the chain communications broken. Gajimata fixes all this, and it's extremely low latency. Even the proof of work meant is low latency, and you know it works as quick as Visa. It's amazing that we've managed to get this to work. So anyway, blockchain doesn't really scale. It's got hard scaling limits. Half of the buzzword projects in blockchain have been to address this particular issue, scale. Everyone wants to know your TPS. They don't even know that they're asking like a silly question. But TPS. The Gajimata branches out to add capacity as needed based on context. And that's a very important attribute to it. But again, that goes back to the core design of the Gajimata, though, trying to solve a real problem rather than beat number go up. And the final, this is a really huge point. There is no one true consensus. Everybody wants a single consensus model for every single transaction out there. That's not how humans make decisions. Not everything can be anonymous and trustless because that has certain costs. Not everything, on the other hand, can be proved by authority or proved by stake, which is kind of a different version of proof of authority. The Gajimata allows you to match consensus model with a context. So there's a universal currency underlying the Gajimata that all of its components all agree on to use. but the consensus governing a specific transaction may vary based on the context of that transaction. And this is the kind of powerful breakthrough that let the structure of the Gaji model even become a thing.